The story of nuclear weapons begins with one word: fission. The idea that splitting a single atom could release the power of 1,000 suns. In the early 1940s, that theory turned into the most secret project in history, the Manhattan Project. Thousands of scientists worked in hidden cities like Los Alamos, Oak Ridge, and Hanford, racing to build the world's first atomic bomb before Nazi Germany could. The result was two weapons, Little Boy and Fat Man. Dropped on Hiroshima and Nagasaki in August 1945, they unleashed destruction the world had never seen. One used uranium, the other, plutonium. Both relied on the same principle. When an atom splits, it releases neutrons that trigger a chain reaction, creating an explosion hotter than the surface of the sun. It took just 2 bombs to end World War II and begin a new era. The atomic age had arrived, and humanity had proven it could destroy itself with science. If fission split the atom, fusion went further. It didn't just destroy matter, it recreated the sun on Earth. The hydrogen bomb, or thermonuclear weapon, works by fusing atoms instead of splitting them. At the heart of the bomb, a smaller fission explosion acts as the trigger, compressing hydrogen isotopes until they fuse and release unimaginable energy. It's the same process that powers every star in the universe. The first test came in 1952, Ivy Mike. The blast vaporized an island in the Pacific, leaving a crater a mile wide. Its fireball reached higher than Everest, and the mushroom cloud stretched for miles across the sky. This weapon was thousands of times stronger than Hiroshima, so powerful that it could erase entire nations in a single strike. From that moment, the race changed. The question was no longer who has the bomb, but who can end the world faster. Not every nuclear weapon is designed to erase a city. Tactical nuclear weapons are built for the battlefield, small, mobile, and frighteningly practical. These warheads can be artillery shells, short-range missiles, depth charges, or even gravity bombs with yields measured in tons, not megatons. They were conceived during the Cold War to stop an advancing army, to blow up a bridge, a concentration of tanks, or an enemy port. Immediate effects, limited area. But limited is misleading. Using a tactical nuke creates radioactive fallout, political shockwaves, and the real risk of escalation. A single battlefield detonation could trigger strategic retaliation, the very spiral planners wanted to avoid. That's why doctrine and control matter. Who authorizes, under which conditions, and how quickly can decisions be reversed? Over the decades, both superpowers built stockpiles of tactical weapons, short-range warheads on artillery, cruise missiles, and special munitions. Treaties and arms reductions reduced some of those numbers, but many states still keep tactical options on the shelf. In 2025, with tensions near hotspots and advances in precision delivery, tactical nukes are once again a dark question for commanders and politicians. Small in yield, enormous in consequence. Tactical nuclear weapons are the paradox of modern warfare. Precise instruments that can shatter the entire strategic order. When people think of the bomb, they imagine strategic warheads, massive nuclear weapons carried by intercontinental missiles, bombers, and submarines. They're the backbone of deterrence, visible, fast, and devastatingly precise. This nuclear triad, ICBMs, long-range bombers, and ballistic submarines, guarantees that even if one system is destroyed, the others can strike back. Modern warheads are smaller yet deadlier. A single Trident submarine can launch multiple warheads at once, each aimed at a different city. By 2025, arms treaties have weakened and modernization races returned. Fewer weapons exist than during the Cold War, but each is more accurate, stealthy, and ready. Strategic warheads remain the ultimate paradox. Weapons built never to be used, yet powerful enough to end civilization in minutes. One missile, many targets. That's the logic behind MIRVs, rockets carrying several nuclear warheads instead of one. Once in space, the payload splits apart, releasing reentry vehicles that guide themselves to different cities or bases. It's precision engineering on a global scale. Born in the Cold War, MIRVs overwhelmed missile defenses. One launch could unleash multiple strikes. Both the US and the USSR mastered the technology through Minuteman, Trident, and SS-18 systems. In 2025, MIRVs are smaller, smarter, and paired with decoys that confuse defenses. One rocket can hit many targets, and no shield can stop them all. MIRVs turned deterrence into mathematics and ensured that in nuclear war, one is never really won. Not every nuclear threat comes from a missile. Some are small, hidden, and terrifyingly unpredictable. A dirty bomb isn't a true nuclear weapon. It's a conventional explosive packed with radioactive material. When it detonates, it doesn't vaporize cities. It spreads panic, fear, and contamination. The blast is minor. The chaos isn't. Even darker are the rumors of Suitcase nukes, compact tactical warheads small enough to fit in a backpack or a briefcase. Officially, they were never built. Unofficially, Cold War archives and defectors tell a different story. The danger of these weapons isn't in their size, but in their invisibility. A dirty bomb could paralyze a city without destroying it. And a missing suitcase nuke? That's the nightmare no one wants to confirm. Speed has become the new form of power. Hypersonic weapons fly faster than Mach 5, maneuver in flight, and strike from unexpected angles. Almost impossible to intercept. Two main types exist: boost glide vehicles, which ride into space before gliding unpredictably back through the atmosphere, and air-launched hypersonic missiles that sustain extreme speed within it. By 2025, the US, China, and Russia have all tested or deployed them. Warning times have shrunk from minutes to seconds, and missile defenses struggle to track low, fast-turning targets. Space-based sensors and automated control systems race to keep up. Hypersonics aren't just faster missiles. They change the rules of deterrence itself. Less time to react, more room for error, and no one fully ready for what comes next. From the first atomic blast over Hiroshima to hypersonic warheads flying at the edge of space, each generation of nuclear weapons pushed science further and brought us closer to the edge. These machines were built to guarantee peace, but only through fear. They define the balance of power and the fragility of it. As technology evolves, one question never changes. Will humanity control the atom? Or will the atom one day control us? If you want to keep exploring the world's hidden weapons and the forces shaping our future, make sure to like, subscribe, and stay tuned for the next secret revealed.